So, hi everyone, my name is Jonathan. To give you a quick background, I feel like I'm a little bit of suffering a little bit from imposter syndrome here because I'm not a food scientist or work in the food ingredient formulation space. My background is actually mechanical engineering and product design. I've slowly found myself into the food tech space over the course of my PhD, where I worked on 3D food printing research, digital cooking. So I come at this maybe from a different angle. So this might be a slightly different take on a normal presentation you've seen, but I'll kind of jump right into it. I am working at the U.S. Army Combat Feeding Division, which is in Natick, Massachusetts. This is where we're located. It's about 30 minutes west of Boston. At this base, our mission, the DEVOM Soldier Center is responsible for the technology, research, development, engineering, fielding, and sustainment for our military's food, clothing, shelter, airdrop systems, and soldier support items. But as it's relevant to this talk, we're just going to focus on food. And more specifically, the Combat Feeding Division, which is where that's located right over there on the map there. So in the Combat Feeding Division, or CFD, we are the global leader and technology provider for military field feeding. And I like to think about this image in the back of my head when we do the work we do at the Army base. I think about a soldier that's in the field, not at a barracks, not at a cafeteria. Think about a soldier that's on the move that has to bring the food with them on their person. So thinking about military rations, containerized kitchens, things that are on the go. So kind of keep this in the back of your head as I talk about some of the research I'm doing. So the CFD is responsible for a number of innovations, which you might interact with on a somewhat weekly basis. A lot of these products, the main innovation did come out of the CFD. As you can see, things like dehydrated milk and egg products, converted rice, high-pressure processed foods, processed cheese, dry yeast, some elements of prepared guacamole, and other shelf-stable products. So again, the major theme here is shelf stability. You want to be able to use hurl technologies and other interesting innovations in the food kind of preservation space to make sure that we can have foods last for a long period of time. One of the design constraints of military rations specifically is that it has to have at least a 3-year shelf life. So if you think about that, it's pretty difficult to achieve while still maintaining palatability, sensory acceptance, and all these other factors. So many of the innovations with a lot of the food scientists and food technologists working at the CFD have innovated a lot in the space to create things that have really high shelf stability and that can last for a long time. But that's not going to be talking to you today about. Today I'm going to be talking to you more about food additive manufacturing. And I know I've heard a lot about food additives. This is not food additives. This is the actual manufacturing process. Some call it 3D printing. I call it additive manufacturing because it's a little more broad in scope. But just so we're all on the same page, this is what additive manufacturing looks like in plastic. This is fused deposition modeling. So it's good for a number of reasons. And there's kind of 3 key benefits I want to touch on here. One of them being customization. We can get really custom in terms of the design that we're creating through this process because we're creating objects from the ground up. But instead of kind of chopping away material the way maybe conventional milling or machining might be, we're adding material layer upon layer so we can get more calculated in the actual designs we want to make. It's great for small batch manufacturing. So if you think about injection molding is probably the opposite of the scale. It tends to work better when you have really high volumes and the cost goes lower. This doesn't have to succumb to that. So you can make things in small amounts. That's why it's good for prototyping. You don't have to use tooling and that sort of thing. And then it's also great for distributed supply chains because you're bringing the manufacturing closer to the end consumer. So you can actually have more deployable machines like you're seeing maker spaces with a lot of these 3D printer fleets that can prototype things closer to the point of when they're actually going to be needed. If we apply this to food in the form of food additive manufacturing, this is what it looks like, a little bit sped up. Customization turns into personalized nutritional snacks at the point of need. So these are the value points we want to look at. We're thinking about food additive manufacturing in the context of the Army right now. So we think about FAM for food additive manufacturing for field feeding. So in the case of soldiers, the reason why we like this idea is for one, provides tailored nutrition. So if we can tailor nutrition for a warfighter or soldier or for any person, we can provide kind of more optimized performance for that person because we're all a little bit different. We might require different micro and macronutrients. It also provides great aesthetic expression. And what I mean by this is it provides kind of a novelty aspect. You get to see things and make them in a way that maybe you're not used to eating. So in turn, you reduce the menu fatigue. So the idea that when you're eating something over and over and over again, so in the case of a soldier perhaps who's on a mission, they have to eat an MRE for 21 days straight, having a little bit of variance, whether it be a little bit the design, the shape, the flavor, it will incentivize them to eat more and ultimately allow them to retain more of the nutritional profile of the food. So these two aspects together in turn, we think is going to contribute to an optimized performance for the soldier and ultimately, hopefully reduce some waste as well in the realm of maybe not eating as many MREs and offsetting some of the packaging and other kind of waste factors that might contribute to this. So I'm going to talk about a study that a colleague and I have been working on, and other people in the CFD. But before I do that, I kind of want to get us all on the same page about nutrition bars, where the current state of the art is. So typically, a nutrition bar might look something like this. I find them to be a little bit one size fits all. Tend to have a limited shelf life, maybe on the order of a couple of months, and they tend to have a pretty basic shape, right? Rectangular, not a lot of innovation. Yeah, extruded stamped. So actually, this may be a form of print, some dimensional printing in there as well. But we're talking about 3D printing here. So this is what a typical nutrition bar might look like. But how would we want to reimagine this, perhaps, with a food printing angle or a 3D food printing application? So perhaps we have a more personalized design or shape. We could tailor perhaps the levels of caffeination or different micronutrient values to provide more energy. It can be made closer to the point at which the person's actually going to consume it, so we wouldn't have to worry as much about shelf life. And then we can also create more intricate designs, which is kind of the factor we wanted to focus more on with this study. So he explained a little bit about the design of the study. My colleague and I, shout out Michael if you're online, we wanted to focus on a couple major kind of hypothetical questions we wanted to answer. First one was, what effect does messaging have on food consumption habits? And by messaging, I mean messaging on the bar. Like, what effect does a message on a bar actually have for food consumption? What preconceived notions do soldiers have with 3D food printing? How does food design affect palatability of food? And we did this all with 17 HRVs. And an HRV is a human research volunteer. And in the case of the people we were working with at the Soldier Center, these were all Army combat medics. So they were all average age of about 22, 18 to 30 age range. So yeah, pretty young. So again, there's also probably some biases generationally with this technology. So it was interesting to kind of see what their takes would be, since they might be the ones who would eventually use this in the field in 10, 20 years time. So that's kind of where we wanted to start out with this idea. And during the course of this, the way we structured the studies, we had a focus group for the first 45 minutes. We split this group into two different groups. We would have a focus group, get their insights, their ideas, we'd ask questions, and we would record it the entire time so we could pull insights from that later. Then using natural language processing, we kind of develop a lot of these results that I'm going to present to you here. This is not published yet, by the way. Soon to be, hopefully, in a review process soon. We'll see how long that takes. So what I'm going to show you in some of these sentiment analyses is we ask different questions, like, who knows what 3D food printing is? Actually, quick show of hands here. Before this presentation, who actually knew what 3D food printing was? Okay, we're working with the food audience. But typically, not only people raise their hand, right? You guys are all very well educated in the food space. So we asked this question. First, we asked about 3D printing. And I'd say about 70% of people knew what 3D printing was. So food printing, maybe about 50 or 40%. So yeah, it's still pretty impressive. At their age, I didn't even know 3D printing wasn't really a thing yet. So yeah, that was impressive to see, but also it gave us a clean slate to work with because they hadn't heard about it, so perhaps they would have their other preconceived notions. And so when we asked them about this, during the course of that discussion, what I'm doing here is this is the average sentiment. And what I did is I looked for comments in our discussion that would say something either negative or positive, and I weighted on a scale of basically +1 or -1, or 0.5 if it was like an agreement in either which way. And that's how I tabulated this aggregate score here. So you'll see as I'm asking different questions, I want to see what the sentiment is over time. So asking about 3D food printing, you can see there was initially some skepticism. When asked about the attributes, you associated with positive or negative things. You could kind of see it again started to kind of dip a little bit more, perhaps start to level out towards the end of this discussion. And this is before I told them anything about what we see the benefits are, like I already explained to you all. And then we asked, what food would you want a 3D printer to make for you? So again, kind of having them internalize the technology a little bit more to think about how it can be applied in their daily life. And this is where it started to kind of tip the scales a little bit, and they maybe started to see a little bit more of the potential. Also, as the discussion is going on, I'm kind of enabling their conversation and trying to understand as well where their inputs are so they could then correct things kind of moving forward. So this was really interesting to see. I'll show you some more of these slides as I kind of go more into this research study. And at this point, I didn't show them anything about the prints yet. And these are some prototype designs I showed them at this point. What we wanted to do here is to kind of prime their thinking, have them understand what this technology can do for them. So you'll see here we have a range. The top left corner is kind of our control. It's a typical rectangular bar design, which we modeled off of a first strike bar, which is a common bar that soldiers have to eat during basic training as like an energy bar. And then we have a number of bars in the bottom that all have different messaging, like power or rest and different orientations. And then we have this really amorphous organic looking shape that I try to go crazy with in option B. Again, there's no real familiarity or base point to kind of point that to. C looks more like a lightning bolt, so perhaps they'd associate that with energy. And then D on the very end is this kind of pentagonal structure, which was twisted and looked a little bit more novel, but with some familiarity as well. So the intent here was to look at what their preference was with no context. Which one did you like? Appearance-wise, whatever. And this is what they kind of came up with. So the control bar, again, somewhere a little above average. This middle line here is neither like or dislike. So what we want are points above here. As you can see, this organic looking one, maybe they didn't really know what to do with it, how we could really use as food, or maybe it didn't look like food to them. So it wasn't rated as high as we wanted, which was okay to see. And then the lightning bolt was also a little bit higher than the control. And then the pentagonal ring structure was actually liked the most, which was great to see, because that's what we ultimately ended up using for our sensory panel at the very end, not knowing this information prior to actually designing it. And then finally, with messaging, as you see here with these two bars, they slightly liked the messaging more than the control, but it wasn't really an overwhelming majority saying they really loved it. So at least they gave us some hope that perhaps messaging would be something that would be of interest to them. They also mentioned other things like maybe they have more custom messaging that would be more pop cultural references for them, maybe like a movie line from a quote from a movie or something like that. You can kind of see how this could kind of affect someone's mentality if you're in kind of a high stress environment and you get a little quote from a movie that might make you laugh as you're eating it. So it was interesting to see this. And so after we showed them these kind of array of bars, again, I looked at the sentiment. There was some kind of discussion. Some liked it, some didn't. Kind of expected, but still roughly neutral after this discussion. And then there was a portion where we asked them to actually draw your own designs for bars. And what would you want the machine to make for you if you had all the abilities at its disposal and all the ingredients to pick from, now that they understood a little bit more about what designs are possible with this technology. And this was really nice to see. So they started to really kind of let their imagination run a little bit more. Again, the designs were a little bit more basic, but they started to kind of internalize the concept of this technology, which was nice to see, and started to kind of change their skepticism to something more of like a mild interest in the technology. So at this point, we then presented these little 3D printed rings to them as a sensory panel. I'll briefly show you what this looked like in the printing process. So this is us printing. This was a cocoa dough formulation. So the base was a kind of tasted like a brownie of sorts, a little bit dry in the middle. I mean, a little bit dry on the outside, like a little bit crustier, but a little softer on the inside. You can see here we can control the infill density of this brownie, so we can create a denser cookie or a softer one, depending on that factor. But what we did is we created the structure, and then we glazed it with a little bit of Nutella on the top as like a slight little topping, which might help the aroma and the flavor profile. And if you're wondering, yes, there's some slight inspiration here from the Pentagon. Oddly enough, I hadn't thought about this till after the fact, but it's actually optimized great for cooking because it is a uniform cross-sectional area. So perhaps this is an architectural design feature as well when they designed it. So I thought that was interesting. So perhaps this could have been a slight bias as well because we're working with soldiers, perhaps the Pentagon. One soldier actually even mentioned that the 5 points is the U.S. Army logo is a star as well. So it's like, oh, perhaps there's some kind of bias here, but I'll kind of touch on this a little bit later in the fact that people like something that's relatable, especially with food. So after the sentiment analysis, after the Sen3 panel, we noticed again there was a slight uptick in the sentiment, which was great to see. So this is ongoing research, which we're looking to kind of finish right now in a paper. I'll make note of a couple other points that I think are interesting to share. This was the sensory analysis from the cookie. So you can see on the far left, the appearance was pretty highly rated, which was great to see. Again, that aesthetic expression they really liked. A lot of them mentioned this could be like something like a novelty cookie design, which they liked. So it was relatable while still being a little bit novel. There was a little bit of subjectivity in terms of texture and flavor, even aroma. You can see kind of the larger error bars here kind of show the variance in responses that we had. I think I kind of expected this. I think people tend to be very subjective when it comes to texture and flavor. Like people are very subjective when it comes to food. They have all of their own eating preferences. And especially if you think about meals that you've enjoyed or you haven't enjoyed, you tend to recount the texture that was a point of contention for you. Like, oh, it was too cold or it was too soft. The pizza didn't have a good crust. So I think this was interesting to see, but it definitely garnered a lot of discussion. Again, using a natural language processing to pick out words, sensory words from the discussion. This is showing you kind of a word cloud of some of the more popular words that were discussed. Again, main ones being appearance and texture related, like shape, design, and texture were big ones. And then flavor and taste there you see as well as kind of secondary ones. Boiling this down into a pie chart, again, appearance and texture were the highest talked about ones. So again, these are important factors that people are talking about and considering when you're looking at food additive manufacturing. So kind of boiling this down to the last main takeaways from this study, which I thought were interesting to share. Perception shifted as we kind of saw from the sentiment analysis from something more skeptical to a mild acceptance. The concerns about the ingredient quality and sourcing was also a really major one. I didn't talk about this too much, but a lot of the soldiers kept kind of their initial perspectives on 3D food printing is that it was something that was synthesized. The ingredients were synthetic perhaps, but I kept stressing that the ingredients are, you get out what you put in. So if you start with good ingredients, you'll get out a good product. The printing process does not do anything to the act, doesn't chemically change the food, it just assembles it, much the same way a chef does when they're in the kitchen cooking food. So that was really important to them. So it's an important thing to note. The mild acceptance was, though the skepticism was converted to mild acceptance after they were educated by it, this concept, which I think was really important to see as well, which kind of just enforces us all. And we heard from previous presentations that education is kind of king with fighting a lot of the stigmas. They enjoyed some degree of novelty. They still wanted something that was related to the ingredients that went into the food. Texture and functional designs were an important thing. A lot of them liked it for the fact that you could cater the design, and that they like the breakability aspect of the food, where if you have little notches like the Pentagon, you could foresee it kind of breaking into quarters or thirds, or for different designs as well. And the customization of nutrition and the shape and the messaging were also really important to them. And then finally, the biggest quote, best quote I had from one of the respondents is they were talking about the identity of the food. Like, it's when things look too far away from the ingredients that went into them, you feel like the food loses its identity, which I thought was a really interesting takeaway. And they said it almost takes the identity out of the food. So I think making sure that we are still staying true to the food that we're making based on the ingredients that we're using is really important. That's a common theme I've also heard today. So these were all very interesting points. This is research which hopefully we put out soon. Lastly, I just have to mention that because I am a contractor with the Oak Ridge Institute for Science and Education, all of the thoughts that have been presented today are my own. But I'm working closely with a lot of colleagues in the Army and developing these thoughts further. So thank you so much for your time.
That was fantastic. That was really cool. I kind of want to eat one. Oh, really? Oh, great. Oh, awesome. Do we have time for questions? We have time for a couple questions here in the audience. I can get one started. Do you think that the filament width affects perception at all? Because you really see that it's printed when it's, and I don't know if it's possible to go skinnier. I just when I think of 3D printing, I think of the finer the filament that you get, the more realistic, I guess it looks. I'm not sure.
Yeah, no, that's a really good point. That was something that we were referring to is with all 3D printing parts, you can tend to see the layer lines that are formed. So that was something that was brought up by one of the respondents too. I think it's difficult because it's a trade-off. You could go really fine and eventually, approach infinity and get really thin, but then the time goes way up. So it's managing that trade-off. I think I could foresee other ways where I've seen companies that have maybe 3D printed products, and the way they get around that is they have some sort of forming technique after the fact. So once they print it, they perhaps have something on a shaper that kind of molds it down, and those lines tend to go away a little bit. So it's the best thing I can think of. But otherwise, maybe you kind of lean into that design design constraint, and you create things that can leverage those layers.
Did you engage in any way with any food manufacturing companies to kind of help guide your questions that you were asking the volunteers, or any other aspect of your approach?
No, we didn't. We weren't guided too much from industry folks, but myself having a lot of experience with this, and some of my other colleagues, a lot of it, I think we already had some burning questions that we wanted answered. So it wasn't terribly hard for us to come up with, I think, some guiding questions to kind of guide the study. But this was the first time I've ever done something of this sort, like a focus group or a sensory panel. So it was really interesting to see. But I'm also open to thoughts from external partners and that sort of thing. But yeah.
Jonathan Roger Clemens. I served in Korea. So did you serve this to any active personnel, like in the battlefield, other than active duty, who might be in civilian life?
Yeah, yeah.
I tell you, battlefield is much different than what you were in attic. So active duty personnel, either in a helicopter or on the ground, they have different perception of what food looks like, and also they consume it very quickly. Totally. So I work with Rangers, and so we eat food very fast.
Yeah. Some of the soldiers were talking about that too. They were talking about with the bars and the packaging, how the texture of it. Because we were trying to think about, maybe there's ways to put messaging on the bar so that you could feel what the bar was by looking at the kind of the tactile feedback. Maybe if it's more raised, it's like an energy bar. If it's more soft, it's a relaxation, like a rest and recovery bar. But it would be really interesting to get the input and to have more feedback from people who have either been active duty like yourself or people who are active duty now. You gum it right away.
We don't look at texture. I think we're trying to have calories.
Yeah. Okay. Well, there you go. That's reality. Yeah, it's true. So it's an interesting take for sure. Yeah, thank you.
I have a quick question. So with the 3D printing, how does that affect the nutritional quality of the food?
Yeah, so like I mentioned, the actual printing process doesn't do anything to nutritional quality. We're just think of it like we're reshaping the food. I like to akin it to if you've done any baking and you pipe the frosting onto a cake. That's literally 3D printing, except you're doing it with your hands. So we're not doing anything to the actual ingredients during the process. The most I would say where you might have some nutritional changes in the food is the cooking, but like similar to normal cooking, there's protein denaturation and other chemical processes that occur. So it's either in the cooking afterwards or the preparation of the actual ingredients for printability. So sometimes if an ingredient is too thin and it won't flow through a nozzle, we might use some gumming agents or things to make sure it's the right consistency. But again, those ingredients are all things that are used in industry. So we're trying to use as many of the ingredients you get at the grocery store. We literally just go to the grocery store, we'll get our ingredients, and that's what we go about it.
Yeah, so we can continue the discussion at the reception, I guess.
Yeah,
So,
that's fine.
all right.
Thanks.